Good morning. So, today we will in the third phase of the non-metal in the biology system. So, while talking about the corresponding nitrogen cycle, we have seen that several important reactions which are mainly controlling the corresponding fixation of this nitrogen molecule, which is a very interesting molecule indeed. So, if we can have N2 molecule in our hand, which can be fixed as ammonia, and depending upon the condition of the medium, that means if it is slightly acidic in nature, we should able to trap this nitrogen as the ammonium ion. And in this particular case, when ammonium ion from the nitrogen is forming, it can also give rise at the same time to the most important nitrogen bearing greenhouse gas, which is nitrous oxide. So, this N2O can be formed over there, or in the reverse way, that means the N2O can be degraded to nitrogen itself. So, when N2O, the nitrous oxide, is getting degraded to dinitrogen, the enzyme system which is involved there are the nitrous oxide reductase. So, nitrous oxide reductase can play some important role to convert this, and which is very important, because if we consider that nitrous oxide is the most important greenhouse gas which do contribute in terms of the corresponding NOx, the nitrogen oxides, and the challenge is there everywhere, from the technology to the corresponding science related to the reaction of degradation, that means the breaking of the nitrogen and oxygen bond to dinitrogen molecule and the oxygen molecule itself is very important. And this N2O can also be formed from the reduction of the nitric oxide molecule. So, this can also be formed through the reduction. So, hence this is forming the corresponding reduction of N2O to N2. So, here the corresponding enzyme system which is present is therefore the nitric oxide reductase. So, nitric oxide reductase we can have in our hand, and from these basically what we can get, we just basically get it from the nitrite ion. So, nitrite ion, when giving us the nitric oxide molecule, again the enzyme system is here is nitrite reductase. So, NO2 minus, NO and N2O. So, all these basically belong to the part of this nitrogen cycle, and this particular thing, that means this NO2 minus and the corresponding nitrate ion, they are basically an equilibrium interconverting system, and this basically goes for the corresponding transformation of NO2 minus to NO3 minus, or NO3 minus to NO2 minus. And when we consider that it is involving the corresponding reduction of NO3 minus to NO2 minus, we get that the involved material in terms of this enzymatic reaction is the nitrate reductase. So, nitrate reductase will be operating on the nitrate ions NO3 minus and can be converted to the NO2 minus. and when NO2 minus is going back to NO3 minus, so we will be working on NO2 minus. So, nitrite oxidoreductase will be there, nitrite oxidoreductase will be there. So, all these steps basically are involving through the corresponding enzymatic systems, starting from the nitrate reductase, nitrite oxidoreductase, nitrate reductase. From here also, this when we are reducing nitrite to nitric oxide, then nitric oxide reductase and nitrous oxide reductase also. So, all these steps basically, that means one we get the corresponding fixation as the corresponding ammonium ion or the ammonia, but in all these cases, that means the conversion of NO3 minus to NO2 minus to NO, N2 and all, these basically we can consider as the typical denitrification reaction. So, this denitrification reaction is basically important. So, if we can have in our system the typical accumulation of the nitrate anions, we can simply go for the corresponding observation of the formation of the corresponding nitrogen gas. So, we get this through the corresponding denitrification reaction. So, how this denitrification reaction can take place in the third phase of this non-metals in biology class, we will see that the typical denitrification reaction is nothing but it is the reduction reaction which is operating on nitrites back into the nitrogen gas, completing the nitrogen cycle. So, whatever we are just talking about during the fixation of this N2 to ammonia and ammonium ion and their interconversion, that means their conversion to N2O, NO, NO2, NO3, and when we are getting back, that means we are coming down from this nitrogen in the pentavalent state in nitrate ion to typically to dinitrogen gas, which is in the zero oxidation state. We consider that this is a very important step of this all these nitrogen cycles. So, this basically fulfills our thing, that means we can go from the corresponding nitrate ion to dinitrogen gas through a process contributing to the nitrogen cycle as the corresponding denitrification reaction. So, this basically can be performed by several bacterial forms. Pseudomonas and Clostridium are the two types of these bacterial species, and typically in anaerobic condition, since these are all reduction reactions. So, reduction reactions does not take the help of the oxygen. So, in absence of the dioxygen molecule, in absence of oxygen environment, we can go for this typical reaction, and the electron acceptor, because the nitrate ion, the nitrate NO3 minus, where the nitrogen is present in the pentavalent state. So, the particular nitrogen can be very much electron greedy, it can take up the electron for its reduction reaction, and this can function as electron acceptor in the place of oxygen during respiration. So, some type of respiration. So, in the respiration, which can be of two types, one is aerobic respiration and another is anaerobic respiration. So, when we have the aerobic respiration, we basically take this O2, this O2 as the electron acceptor, and in case of other cases where anaerobic condition is prevalent, we get the nitrate and other nitrite and all other things as the corresponding electron acceptors. So, these are the typical electron acceptors for the respiration in case of aerobic condition and in case of anaerobic condition. So, since we are talking in terms of the corresponding bacterial processes, so the faculty for this thing, the facultatively the anaerobic bacteria, which is very intelligent though, can also live in aerobic conditions also, because the electron what they are demanding, what they are accepting is taken up by the nitrate anion and the most oxidized form of the nitrogen, and it can also survive therefore in also the aerobic condition. That means where oxygen, if it is present, will not interfere with the corresponding reaction of all these bacterial species. So, this particular case, if we just consider this anaerobic ammonium ion oxidation, which is a very important reaction. So, we will be considering the oxidation of ammonium ion. So, if we have ammonia or NH4 plus is the corresponding ionic form, and if we just consider their oxidation, so how we can go for the corresponding oxidation of these two species, and this is also a typical biological reaction. So, biochemical things we should follow. So, for that the biological reactions we should follow, and these reactions are therefore important when a particular biological reaction which is operating on ammonium ion and we do not have any oxygen present over there. Therefore, it is the anaerobic condition which is responsible for the oxidation of ammonia. So, nitrite as well as ammonium ion are converted directly to molecular nitrogen. That means, the nitrogen gas can be produced through the reaction of nitrite and ammonium ion. So, the nitrite ion, the nitrogen in nitrite ion is getting reduced and nitrogen in the ammonium ion is getting oxidized. That is why we call it as a corresponding reaction responsible for the oxidation of ammonia or ammonium ion. So, it is basically a major proportion of nitrogen conversion in the ocean. So, in the ocean we get large amount of nitrogen present in ocean environment, and if the corresponding nitrite and ammonium ion can react to produce the dinitrogen gas, where the source for this nitrogen is both the nitrite ion and the ammonium ion, then we can think of the nitrogen gas whatever available is due to the oxidation of ammonia or ammonium ion. So, if we consider that a condition where in anaerobic condition ammonium ion is getting oxidation, so is the abbreviated form is known as NMOX. So, N is the anaerobic form, N from the anaerobic reaction, M is from the ammonium ion and oxidation, OX is the. So, NMOX is a globally important microbial process of the nitrogen cycle. So, bacteria can take part now, bacteria can interfere for the corresponding nitrogen balance, corresponding nitrogen cycle and the amount of nitrogen bearing elements. That means whether we have the nitrate ion or nitrite ion or ammonium ion into the system, that can be controlled through the interference of the microbes, and they do take part in the corresponding nitrogen cycle. So, the typical reaction is a very simple reaction where ammonium ion is reacting with the nitrite ion forming dinitrogen and water molecule. It is a very simple and straight cut reaction, but not that we always get this reaction in the laboratory, and in the environment, in the natural process we get this particular conversion. So, both these two ions, the anion and the cation, the nitrite and the ammonium, they are directly utilized for the generation of nitrogen gas, and it basically contributes about 50% of the nitrogen gas produced in the ocean. So, oceanic environment is also responsible for the production of nitrogen gas in the environment. So, whatever species we have in the ocean water, that can be utilized, and the bacteria present in the ocean environment, they are responsible for the corresponding degradation of both the ammonium ion as well as the nitrate ion for the useful production of nitrogen gas, which can no longer be trapped in the water molecule of the ocean. So, they basically leave the ocean water system and can contribute to the corresponding introduction of this nitrogen gas in the environment. So, how we apply is a very simple and very useful reaction of this Anaerobic process. If we want to remove the ammonium ion in wastewater treatment, so how we can have, so we get basically something, if we have both these two, that means the ammonia as well as ammonium ion in industrial effluent in the corresponding city water level, that means the corresponding wastewater. So, if this is present in wastewater which is getting polluted due to the presence of a high level of high amount of these nitrogen bearing inputs. So, in the wastewater, if we have ammonium ion as well as the corresponding nitrate ion. So, if we have the ammonium nitrate basically, so what the salt which is present in the wastewater is the ammonium nitrate. So, the presence of ammonium nitrate is therefore is a typical concern, because high level of this ammonium nitrate is not good. These are harmful for our health. So, they can have some severe health effect. So, this is basically harmful to the living organism, and they can contribute to some other important reactions which are mainly controlled by the presence of the ammonium ion as well as the nitrate ion. So, if we can take the typical anaerobic ammonium ion oxidation, and if we just consider one such reaction, that means where ammonium ion is taken care of. So, in the first step, a typical reaction what we can have is the partial nitrification of half of the ammonium ion to nitrite by ammonia oxidizing bacteria. So, this is a bacterial reaction, and bacteria is present over there, and in that particular case the ammonium ion is simply oxidized by the dioxygen molecule, but this oxygen is coming from some aerobic condition. So, is not a typical anaerobic condition is present. So, in the first step where we are utilizing the dioxygen molecule, so utilization of this dioxygen molecule for the corresponding degradation of this ammonium ion to nitrate ion can be considered like this. So, half of the ammonium ion, that means 2 of these NH4 plus is converted 2 of the corresponding NO2 minus, and 2 remains as corresponding ammonium ion, and some proton is also forming, H plus ion is forming together with some water molecule. And in the second step, so if we have the corresponding these two species, that means in solution we have both ammonium ion as well as the nitrate ion. So, this is the corresponding Anaerobic reaction which is not required any oxygen. So, is in typical anaerobic condition. So, in typical anaerobic condition, when half of the ammonium ion has generated nitrate ion, so the presence of nitrate ion is important. So, the generation of this NO2 minus generation from where? From the ammonium ion is therefore important. So, once it is in form, we already have the ammonium ion in the system. So, this what is we are talking about, these are generated. So, within the reaction medium, that means in situ we are generating some amount of nitrate ion, and that nitrate ion when react with the ammonium ion can go for the typical degradation with the production of only nitrogen gas. So, these two, that means the ammonium and the nitrate ion are converted by this process to nitrogen gas and 15% of the nitrate ion also. So, this reaction is not only for the direct conversion of both ammonium ion and the nitrate ion to nitrogen molecule, the nitrogen gas, but at the same time some amount of side reaction can take place. So, as byproduct of this reaction, we get some amount of nitrate ion also through this particular reaction. So, what bacteria can do for us, we can take this bacteria in some closed vessel, in some reaction vessel, what we call as a reactor, where two guilds of bacteria form compact granules. So, if the granulated bacteria are there, bacteria are trapped within the granules, and those granules are exposed to the solution bearing the ammonium ion and the nitrate ion. So, this basically can go for the corresponding elimination of both these two. So, if the wastewater, the sewage water or the drainage water from the municipality, where we have all the nitrogen bearing materials, because they are coming from all the nitrogen bearing molecules like the fertilizer, the proteins, the amino acids, all nitrogen bearing compounds. So, if we have several of these nitrogen bearing compounds in our hand, and they are basically also present in the wastewater. There are several nitrogen bearing compounds also present in industrial wastewater. So, industrial wastewater, several of these nitrogen bearing compounds are present, particularly if the industry is based on some fertilizer production industry, if they are dealing with some fertilizers, manufacturing of some fertilizers. So, they definitely will have some all these nitrogen bearing compounds, where the nitrogen level, the nitrogen concentration is very high and the wastewater should be treated. So, this Ammonox treatment, so this particular treatment, that means the bacterial treatment. So, both these, that means simple groundwater contamination can be avoided if we can go for the corresponding treatment by using some bacteria only. So, bacteria is therefore very much helpful for us to remove these all nitrogen containing contaminations, all the nitrogen bearing elements to the dinitrogen gas, and this dinitrogen gas can be removed to the environment. So, from this, that means after this nitrogen cycle, we can now consider another very important non-metal which is playing some important role. That means they are playing some very good contribution towards some important biological reactions, which is the iodine, that we all know nowadays that iodine supplement what we are getting as the corresponding salt, the common salt, the table salt as the corresponding sodium chloride, because iodine can give rise to some important reactions in our health, for our good health also. So, it is a very necessary trace element for our life, for the human being also, and it is definitely a heavier element and is known for the heaviest element regularly needed by living organisms, and is therefore a second heaviest element, because already we have discussed while we are talking in terms of the corresponding enzymes bearing molybdenum and tungsten. So, tungsten was the heaviest one, and after tungsten we have the corresponding elemental composition for all these biologically important molecule is due to the iodine. So, in terms of the corresponding atomic weight, we consider it is the second heaviest element which can have some contribution towards some biological reaction and which can be used by any form of life. So, human being is also important and also dependent on the corresponding iodine concentration. So, how iodine can be useful for our health, that we can see. So, these are the two thyroid hormones. So, iodine deficiency is basically lead us to some diseased condition. So, if we have this I2, the iodine, and we basically get this particular in our food material as the corresponding salt intake. If we are not getting sufficient amount of iodine from the other food materials, so as salt along with our sodium chloride intake, we get the corresponding iodine intake also. So, this iodine is utilized for the production of hormones basically. So, while we are talking about the corresponding vanadium dependent enzymes, so vanadium chloroperoxidase and vanadium bromoperoxidase, we have seen that we can go for the insertion of the Cl, that means the chlorine atom or the bromine atom, to some organic substrate or organic molecule by the corresponding chlorination and bromination reaction. Similarly, if we know that all these hormones are bearing some iodine fragment within the molecule, that means the basic important reaction for the generation of these hormones would be iodination. So, iodination reaction we can talk about. So, how in a very mild and very soft condition the biological environment biological environment, how they can go for some important iodination reaction when we have the corresponding iodine bearing salt, where we have iodine as present as the corresponding iodide ion, like chloride, like bromide, we have the iodide ion. So, this iodide can go for the generation of two such hormones, and it is the thyroid gland. This particular thyroid gland is controlling everything. So, two such hormones we can have. One is known as thyroxine and is also labeled as T4, and another is known as triiodothyronine. This is also thyroxine. This particular thyroxine is also known as tetraiodothyronine. So, when we have the corresponding organic molecule as the derivative bearing 4 iodine atom, we call it as the corresponding tetra or T4, and when it is the triiodo derivative, that means we have 3 iodine atoms within the molecule, we call it as a triiodothyronine. So, we must have some substrate where 4 iodine atoms should be incorporated within the molecule, and in another case 3 such iodine atoms can be incorporated within the molecule, and they play some important role related to our thyroid hormones. So, the molecule which we get is a typical amino acid, and which is our tyrosine. So, tyrosine molecule we can have, so is plenty in amount in our body also. The amino acid tyrosine is everywhere in our system, in different proteins and polypeptide chains also. So, if we can generate some amount of tyrosine from there, different food materials also can supply tyrosine. So, there are several tyrosine bearing food materials also there. So, we have regular intake of these tyrosine molecules in our system, and these amino acids, they are iodinated. So, they are basically stored to released in an iodine containing protein called thyroglobulin. So, some iron containing protein we can have which is related to the thyroid gland, that is why it is named as thyroglobulin. So, if we have this particular amino acid as their typical backbone or the substrate, so like our vanadium bearing enzymes what we have seen, which are responsible for the corresponding conversion of the molecule from its non-chloro or non-bromo derivative to its corresponding chloro derivative to that of our bromo derivative. Similarly, we have the corresponding tyrosine residue. So, the tyrosine residue what we have in our hand, which is basically the amino acid, the very simple amino acid bearing the phenol unit, and this particular one this part is basically the corresponding amino acid parts. So, like that of our glycine molecule. So, is the amino end we can have, and we have the carboxy end. Therefore, it is basically a para substituted phenol unit. So, para substituted phenol unit is the pendant unit to that of our glycine molecule, which is our tyrosine amino acid. So, if we have the tyrosine molecule in our hand, and this tyrosine molecule can react or interact with that of our iodide ion or the free iodine molecule. For the reaction is our typical iodination reaction. So, how we can have the corresponding iodination reaction? That means, if we can have the simple phenol unit we know that this is a very simple and straight cut reaction. That means, phenol can be brominated by the use of simple or elemental bromine or bromide bromate mixture. That means, if we add the bromide ion as well as the bromate ion. So, this basically these two, that means a bromide bromate mixture. This bromate is nothing but the corresponding oxidizing agent. This is the oxidase. So, bromate can function as a typical oxidase for the production of this Br2 molecule, and this basically responsible for the corresponding substitution of these three positions with respect to the phenol OH function. So, we get straight away from there the molecule like tribromophenol. So, this tribromophenol can very easily be made with the addition of bromine to the phenol molecule. Similarly, if we can have the tyrosine, and if we are looking for some typical or the corresponding iodination reaction which is present in the protein part, that means the protein thyroglobulin, is there. and that thyroglobulin can handle this iodine to be inserted. So, these are the two ortho positions similar to that of our tribromophenol, which can be iodinated with respect to the phenol OH. So, this is the simple possibility where the generation of the typical hormone can take place, whether the simple iodination reaction can convert the tyrosine, whether we get the simple tyrosine as we get the tyrosine, and whether the tyrosine, how the tyrosine is responsible for the generation of these two important molecules, the triiodothyronine and the tetraiodothyronine, that means the T3 and T4 molecule. So, what is that particular reaction? Because we always know that depending upon this corresponding deficiency in iodine, that is why we take all the time the regular salt, the table salt, what we take in our food, as which should be supplemented by the corresponding iodine. So, the iodine availability should be there, which can be utilized for the tyrosine iodination for the production and the generation of the hormone. So, this hormone biosynthesis is therefore important. So, this biosynthesis is dependent. So, this hormone biosynthesis, that the formation of T3 and T4 is basically dependent on the corresponding concentration of I minus or the I2 molecule. So, this particular thing, that means the iodine containing protein thyroglobulin, which is basically stored the corresponding iodinated form of this tyrosine molecule. So, this is some example of this thyroid gland, and is basically is the corresponding larynx and trachea we have. So, this is our larynx, that is the vocal organ where we utilized it for speaking our thing, that means, and we have the trachea, and this entire part is surrounded by the very big thyroid gland, and thyroid gland is we can have, which is responsible for the production of these all these important molecules as their corresponding hormones. So, the TG is we have the thyroglobulin is basically a very big protein molecule, is having a molecular weight of 660 kilodalton. So, this 660 kilodalton bearing dimeric protein, that means it has two parts basically, which is formed by and used entirely within the thyroid gland. So, thyroid gland is responsible for the use of this thyroglobulin protein molecule, and thyroglobulin molecule is responsible for handling these molecules like these T3 and T4 molecules. So, when we have this thyroglobulin, thyroglobulin is bound to T3 and T4 or T3 or T4, and when in the bound condition they are known as the corresponding colloid form. So, in thyroid, the gland we have, so the human being also we have this particular thyroid gland, and this thyroid, within this thyroid gland we have the corresponding protein molecule, which is the TG. So, thyroglobulin, and that thyroglobulin is responsible for binding the T3 and T4. So, therefore, we can see how these T3 and T4 molecules are formed from tyrosine molecule itself, and they are going there basically and bound to the corresponding thyroglobulin molecule. So, these T3 and T4 are very important molecules. So, why they serve as this T3 and T4 molecule, why they are so important. So, these T3 and T4 are responsible for one very important reaction in our body, is responsible for controlling the metabolism. is a very important reaction in our body. So, if we can have the corresponding sufficient amount of this T3 and T4 molecule, we can have good metabolic rate and we can have useful metabolism reactions for the food material, the respiration, everything. So, basically we see that metabolism is also therefore dependent on the non-metal component, that means the iodide ion. So, iodide iodine dependent metabolism reaction is there because both these two molecules, these two hormones T3 and T4 can control our body metabolism reactions. So, this is not entirely the corresponding iodinated form of the tyrosine, though this is the tyrosine part, but is basically a bisphenol molecule. So, the bisphenol molecule is there. So, from the tyrosine we basically get a bisphenol type of molecule having two phenyl rings. So, for getting a system like T4 and getting a system like T3 through iodination reaction. So, whatever reaction we have in our hand is utilizing these I minus or I2 in situ generated I2 through some oxidation reaction. So, these iodination reactions, so this particular iodination reaction can take place if we can have one benzene ring, and this particular benzene ring can have two ortho positions. So, T3 and T4 can only be possible if we have two such benzene rings which can give rise to 4 ortho positions with respect to the corresponding OH groups available. And if this is attached to the second molecule, we get a corresponding bisphenol molecule. So, we have a bisphenol unit, and this bisphenol unit is utilized for iodination. So, when all 4 positions are responsible for iodination reaction, we get a T4 molecule, and when only 3 positions are occupied for iodine derivative, we get the corresponding T3. So, this is the corresponding T4 molecule we have, where 4 of these positions, 2 ortho of this OH group and 2 of ortho to this thioether molecule of this bisphenol unit, we have the T4 molecule in our hand. Similarly, when we have this first of these, that means which is directly attached to the amino acid fragment at the para position, or both are occupied, both the 2 positions, the positions 2 and 6 basically are occupied by iodine group, and the second phenol unit having one iodine unit group to one of the ortho position, we get the corresponding T3 molecule. So, we will see that how these 2 molecules can basically take part in the corresponding important metabolic pathways for our system or our body. So, if we have some deficiency of iodine, that means the deficiency of iodide ion as we are consuming our body. So, if we have less amount of this iodine in our system, so less amount of iodination can take place, though this bisphenol type of molecule can form, but the iodination reaction cannot take place, but the effective hormone, the real hormone what is being formed over there is basically the corresponding molecule having these iodine derivatives. So, any kind of deficiency of iodine basically leads to decreased production of T3 and T4. If the concentration of iodine or iodide ion which is required for the regular production of T3 and T4 is sufficient, then only the required amount of T3 and T4 can be formed in our body. Otherwise, we will have some less amount of T3 and T4 in our system. That means we are having some deficiency of iodine as well as deficiency of T3 and T4 molecules, and the diseased condition for that means if we have a deficiency of T3 and T4, we will see that we are having goiter. That this goiter is nothing but we have the thyroid gland, and that thyroid gland will be enlarged, because if it swells off, if it has a bigger volume, if the thyroid gland size is increased, it will try to absorb more and more, is basically fighting for more amount of iodine absorption. So, if the iodine absorption is less, there is deficiency, the iodine is not getting to the system, and the less amount of iodine can be considered as the corresponding enlarged thyroid gland, because thyroid gland will next try to enlarge itself and try to increase its surface area, and through that surface area it will try to accumulate more and more iodine to the system. So, we will be having a diseased condition which is known as goiter, is well known from our childhood days, from our school days. We all know how the goiter is there, but now we come to know that it is the deficiency of the inorganic ion, that means the iodide ion or the nonmetal element iodine, which is responsible for this condition. So, if we have in our system the main form, what is forming over there is the thyroid hormone in the blood is the T4, which is known as the thyroxine or tetraiodothyronine. So, this T4 when is forming in our system, we call it as a thyroxine So, this thyroxine is nothing but the corresponding tetraiodide derivative. And this is the corresponding triiodide derivative. But these two compounds have some difference in terms of its corresponding lifetime. So, the T4 has a longer half-life than T3. So, whenever T3 is forming in our system, it is degrading very quickly, it has less half time compared to our T4. So, T4 is the more stable compound, so T4 will stay in the blood for longer period of time. But the two ratios, that means the formation of T4 and T3, what is forming over there and released into the blood is roughly 20 to 1. So, more and more T4 can be formed in our body, and in the bloodstream the concentration of T4 would always be the higher, that means it is always 20 times higher. Basically, it is 20 times higher than the T3 which is available in the bloodstream. But another very interesting reaction is the corresponding involvement of some enzyme, so which can be responsible for a typical catalytic reaction, which is nothing but the removal of the iodine atom from the phenyl ring attached to the bisphenol unit, which is known as deiodinase, that means which is responsible for deiodination reaction. So, deiodinase, which is taking the 5' iodinase reaction, that means it is taking out that particular I group from the T4. So, the reaction what is forming over there, which is operating. So, these deiodinases, so iodothyronine deiodinases, so we call them as iodothyronine deiodinases. So, we have the thyrronine molecule which are iodized. So, iodothyronine deiodinases. Abbreviated as DIO, deiodinases. So, this basically catalyzes the corresponding reaction which is known as deiodination reaction. We have seen so far that the introduction of these iodine atoms to the phenyl rings attached to ortho position of the OH or O group is known as iodination reaction. So, this will be our deiodination reaction. So, through this deiodination reaction, what we will basically get, we can be able to convert the T4 molecule to T3 molecule, and which is very interesting to know that we have these 4 iodine positions and we are taking out these iodine atoms from these rings. So, we can have the possibility that I can be removed from this ring or I can be removed from that particular ring. So, the removal of I from one particular ring which is leading us to the generation of T3 is the most acceptable reaction for this particular pathway, that means the deiodination path for the conversion of T4 to T3 is therefore very important. So, when deiodinases are operating there, these particular molecules are further processed by decarboxylation and deiodination to produce iodothyronamine and thyronamine molecule. So, decarboxylation can take place also, that means CO2 group can remove from the molecule and only some benzyl amine type of derivative can be present over there from T4 and T3. So, there are 3 forms, isoforms basically of deiodinases. So, these deiodinases molecules are some enzymes, and we will just introduce the first time that the selenium atom, the selenium is there which is important in the biological reactions. So, like that what we are seeing today, the reaction of iodine in biology. So, what we will be talking in our next class as the corresponding involvement of these selenium groups, the selenium containing enzymes. So, now today we will see that this selenium bearing enzyme is also important, that means these are very much interrelated, that means the corresponding reactions involving iodine or iodide ion or the reaction involving the selenium atom, they are interrelated because the deiodination reaction can be controlled by some enzyme which is bearing the typical selenium atom. So, in the form of otherwise rare amino acid selenocysteine. So, when the cysteine is there and cysteine sulfur is bearing selenium atom, we get the corresponding amino acid as selenocysteine, and that selenocysteine is present in this particular enzyme. And therefore, like that of our iodine, in our food material, in our diet, we should have also selenium, which is essential for the production of T3. So, now at this particular point, we should be able to tell you that why selenium is important, why selenium as well as iodine is important for the treatment of goiter, because the less amount of T4 will lead to less amount of T3 production, because for this deiodination reaction we will see that T4 is directly converting to T3, and that particular T3 is responsible for our metabolic reactions. So, whatever thing we can have, that means what we just basically go for the corresponding deiodination reaction. So, basically if we have the enzyme which is the deiodinase. So, deiodinase, now we see that it will have the selenocysteine amino acid. So, this particular selenocysteine amino acid is therefore there, and this basically is responsible for the conversion of the corresponding T4. So, we can have the T4 which can be converted to T3. So, for the production of T3 we should have selenium bearing this protein peptide chain, and this particular is responsible for the corresponding removal of this one of the I group from T4. So, that basically giving us TiO selenium, and this selenium is basically taking up this iodine, and the cycle can be closed since it is a typical catalytic cycle for that, where we use some reductant to convert this particular oxidized form of this deiodinase to the reduced form of this. So, we have the reduced reductant which can be converted to its oxidized form as oxidized reductant. So, that basically gives us some idea that how selenium is playing some important role for the generation of this selenium iodide bond, which is very important. So, next day we will consider this particular element, that means the selenium towards the corresponding metabolic pathways, because the iodine is important for the generation of this T3 and T4. This basically when taking part one proton also is generating the corresponding T3, how selenium is important for the generation of T3 molecule. Thank you very much.